Hello, everybody. I hope you guys are doing okay. I thought it might be kind of an interesting thing to think about some of the concepts that you've worked on in mathematics, but you've never really seen it in application. So, why outbreaks like coronavirus spread exponentially and how to flatten the curve? Okay, so this article written back on March 14th kind of discusses or creates models around the idea of the coronavirus and its spread. And so what we see here is we see this beautiful graph, which I hope you guys can identify as an exponential function. And we remember an exponential function is going to have the form y equals a times b to the x power. And so we know that a, if you don't remember, I'm telling you, a is just a coefficient. And so sometimes if we're dealing with money, this will be the initial amount of money that you start with. So this is, I'm going to call it the initial amount, right? And so let's do that. And b is going to be kind of my rate of increase or decrease. And so as long as b is greater than 1, we have an increasing situation. And now if b is somewhere between 0 and 1, like some fraction or decimal number, we have a decrease, right? And so as we're dealing with the model that we're looking at here, let me go back. As we're dealing with this model, clearly our b term is going to be a positive. It's good, not just positive, all of the b terms have to be positive in a function like this, but the b term is going to be greater than 1. And that greater than 1 situation means that we have growth. So that's why we call this an exponential growth as opposed to an exponential decay situation. And so I was thinking about this, and this is my first question to you guys. As we look at this model, right? As we look at what's happening, we see on January 22nd, we've got one reported case, and slowly, we've got this increase. And of course, we're dealing with people, so we can't have fractional. We can't have like 1.795, right? That doesn't make sense. So this model is an approximation of what we think is going to happen. Today is, I believe, March 30th. At this point, what day is it? Okay, today is March 30th, I think. And the last value that they had here was from March 13th. And I wondered if any of you, I'm not going to ask you to come up with the equation, but if I did have an equation that modeled this particular curve perfectly, and then I put in the numbers, whatever number of days from January 22nd to March 30th, and I plugged in the numbers, and I saw what value I would get, right? Like I can use that value. Do you think that value, that predicted value based on this supposed equation, would equal the exact value that we have today, right now, March 30th? And I think we're somewhere over 150,000 people. Now, exponential curves do grow rapidly like that. Do you think it would be the same if we use the exponential function that models this equation? We're just supposing. I'm not even asking you to come up with that equation. So if I had that equation, would it match the value, would the predicted value using that equation match the value we have today? And I want to hear back from you, why or why not? Why do you think it would? Why do you think it would? What are some variables in our community that may or may not impact whether or not we can get a truthful prediction, whether the predictions are truthful based on the data that we've got before right now? All right, up to the 13th. Okay, so with that in mind, I'm going to move on because I thought this article was kind of dope. It kind of talks about a couple things, and I just wanted to show you what some of the reasoning, and kind of discuss a little bit of reasoning why you're home, why you're not hanging out with your friends, why you shouldn't be, why you're not hanging out with your friends, and why you are, not in places where you want to be, like, school or something. Okay, so here's what I have. If you look at this model, I'm going to go ahead. This is what happens if you took a group of 200 people with a couple unhealthy people in the mix, and then you just let it go over time. Now, we just talked about this having an exponential effect, and it does have an exponential effect, but the reason why you're not going to see it go off forever and ever, because we know exponential functions have a range, meaning it goes up forever and ever. We can't, because people will get sick, and then they will recover. And then, here's the thing, we don't have an infinite number of people in the population. So this 200 people situation, you just saw the dots moving close together and people getting sick, and then we have this pretty high hill. The problem with this high hill, and it's beautiful because you're like, hey, some people are healthy, some people get sick, and then you get healthy again. One is that people are also dying, right? So this doesn't necessarily show that. It just shows everybody recovers. And we like that to be the case. But people, it's a small percentage, but people are passing away from this disease. But the other thing that's really important is that this hill right here, this is too much for our current medical community to handle. Right now, they're overtaxed. If you got a parent or a friend or a loved one or a family member that's working in a medical community, you will know how stressed out and difficult this situation is. And so, in a sense, the prediction was that, hey, we can probably deal with about this amount of people getting sick, about half of the amount, half of this maximum amount getting sick at one time. And so there were some ideas about how to handle that. So one was this idea of quarantine. So if you lock people into a certain place, they all gonna get sick. But when that door opens, even if it opens slowly and you let some people out, they're gonna still have the contagion. They're gonna still be ill to a certain extent where they could spread it. So we do get an original flattening over time. But as these people move through the community, you'll get a spike. And again, that spike is going to be too much, right? And so we could look at another situation where we're looking at more sheltering in place. Let me see if I can do this one over again. We're looking at sheltering in place. You notice that I call it sheltering in place, quarantining. We notice that a lot of people are, not moving around that much, but we still have people who are working, who have to go, doctors, nurses, truck drivers. You've got, grocery delivery people, all of these people who are making our community still run. They're out there, and they too are a part of the movement of the virus, unbeknownst to themselves sometimes. They're not sick, but they're moving things around. And then we have another situation where if more people were to stay put, even fewer people out there moving around, we have a situation where you see that the growth is really slow. And the reason why we want, it doesn't mean that there are going to be people who don't get it necessarily. It just means that it's going to spread slower. Hopefully, people can avoid getting it. There'll be a vaccine, there'll be some kind of a cure. But what we see here is, notice 52 of these people, of the 200 people recovered, 119 are still healthy. They haven't gotten, only 29 sick. And so that's what, when you hear on the news, they're talking about flattening the curve. They're talking about flattening that huge spike in people getting sick, where our medical community and our medical personnel just can't take care of that situation. So as you are thinking that you're stressing out at home and you're like, oh my gosh, why do I have to do this? I don't get sick. Kids don't get sick. Kids do get sick, unfortunately. I'm stressed out about that for my own family, and grown-ups get sick, and we need to take care of the grown-ups and the adults in our lives and the people that we want. So encourage grandma and them to stay home. Encourage, whoever to, remain at home and wash hands and take the precautions seriously. Take the precautions seriously. Look, I love and miss you guys very much. I hope that all is well. If you can, give me some of the question I asked earlier, some of the data points that might make the model that we had up to March 13th untrue, some of the data ideas that might affect the data, rather, that might make our March 13th prediction for this day, for March 30th, untrue. I'd like to hear back from you. Look, take care of yourselves. Make sure you're still doing your schoolwork. If you need any help with math, let me know. And I look forward to talking to you guys soon. Bless you. Bye-bye.